Next, after the LC circuit, now see the power in AC circuits. V is equal to V naught sin omega t. I is equal to I naught sin omega t plus pi. Already we know these two equations very well. Instantaneous voltage at any instant of time, instantaneous current at any instant of time, and voltage and current are differ in phase by pi. Differ in phase by pi. Now, if you want to find the power, power is equal to V into I. In place of V, I can use V naught sin omega t. In place of I can use I naught sin omega t plus pi. Then we will get V naught I naught sin omega t into this, we can write it as a sin A cos B cos A sin A. Sin A cos B cos A and sin B. Next, if I am multiplying these two, V naught I naught sin square omega t cos pi plus V naught I naught sin omega t cos omega t into sin pi. Now average power over the complete cycle is given by P is equal to 0 to T. The total equation I have right, V naught I naught sin square omega t cos pi plus V naught I naught sin omega t cos omega t and sin pi. By solving that equation, finally we can get the power equation P is equal to V naught by root 2 I naught by root 2 into cos pi. V naught by root 2 I naught by root 2 into cos pi, or you can write P is equal to VRMS IRMS into cos pi. Now everybody must remember this equation. The power in AC circuits is given by P is equal to VRMS IRMS cos pi. Rest of the derivations, no need to worry, but remember this final equation. P is equal to VRMS IRMS cos pi. Now in this equation, this P we call it as a true power, and this VRMS IRMS we call it as a apparent or virtual power, and cos pi we call it as a power factor. Now this power factor can be defined as cos pi is equal to R by Z, or R by square root of R square plus XL minus XC whole square. So like that. And this power factor can be defined as ratio of true power to the apparent power, and that ratio we call it as a power factor. Next, suppose if the voltage and currents are differ by pi by 2, if the voltage and currents are differ by pi by 2, in such a case the power factor cos pi is equal to 0 and power consumption is 0. If the voltage and current are differ by pi by 2, such a case power factor is 0 and power consumption is 0, and such a current we call it as a wattless current. Wattless current. What is the meaning of wattless current? The current which is passing through pure inductor and pure capacitor. Such a current we call it as a wattless current. Or the voltage and currents are different by 90 degrees. In such a case, power factor is 0 and power consumption is 0, and such a circuit is also called as, such a current is also called as wattless current. Now you see the power for this resistor, power for capacitor, power for inductor, and all these things one by one. Now see, for resistor, the power equation is P is equal to Vrms Irms into cos pi. But here the pi value, there is no phase difference, pi value 0. The pi value 0 means cos 0 1, and finally the power equation is given by P is equal to Vrms into Irms. This is true for resistor. Whereas in case of for capacitor and inductor, where the pi value is equal to 90 degrees. In such a case, P is equal to Vrms Irms into cos pi by 2, cos 90 value 0. So that is the reason power is equal to 0. So everybody must remember these important values. Once again, see, the power in AC circuits is given by the equation P is equal to Vrms Irms cos pi. This P we call it as a true power. This Vrms Irms we call it as a virtual power, and cos pi we call it as a power factor. And for resistor, pi is equal to 0, then we get P is equal to Vrms into Irms. For capacitor and inductor, the phase difference between voltage and current is 90. In such a case, P is equal to Vrms Irms into cos 90. Then the power factor will be, will be 0. The next concept is LC oscillations. LC oscillations. For this LC oscillations, I am taking a diagram like this. This is inductor. It is connected to one capacitor. Here one plug key is there, K2. For this one cell is there, and again here one more key is there. Now see here, this is the key K1, this is the key K2. Initially K2 is open, K1 is closed. Okay. If the K1 is closed, what is happening? The battery is connected to capacitor. If the battery is connected to capacitor, what is happening? The battery is supplying the potential to the capacitor, and slowly it is charging. It is charging, and finally at a certain time the energy becomes maximum. The maximum energy is electrical energy. The electrical energy is given by UV is equal to half CV square or Q square by 2C. Once it reaches the maximum, then what is happening? I am opening the key. K1 is open. Then what is happening? Next, I close this key. Then I am not including the circuit. Now the circuit is almost removed. Now what is happening? If key K2 is closed, the capacitor is connected to inductor. Then what is happening? The capacitor is giving energy, and current is passing to the inductor, and slowly magnetic flux is changing. Because of this magnetic flux, induced EMF is produced, and this induced EMF is trying to oppose the effect, and that is the reason that slowly this electrical energy is converted into magnetic potential energy. Then after certain time, the total electrical energy is converted into magnetic potential energy. That magnetic potential energy is given by half L I square of L I square. Then afterwards, if it is completely converted into magnetic potential energy, here there is no passage of current. If there is no passage of current, there is no change of magnetic flux linked with the inductor. Then there is no induced EMF. Then what is happening? And slowly this inductor is discharging that magnetic energy. And finally, again, the capacitor is storing the energy in reverse direction. First, if it is positive, here negative. Then afterwards, this becomes positive, and here it becomes negative. And the capacitor is storing the energy in reverse direction. Then once again it becomes maximum. Once again it becomes maximum in opposite direction. Again, once again the electrical energy is maximum. And later, once again it is discharging and magnetic energy is maximum. So finally, here, if the capacitor and inductor, if the both are not offering any resistance, then the energy is oscillating between capacitor and inductor. Only there is no loss of energy. Only here the energy is oscillating between capacitor and inductor, and such a oscillations we call it as a LC oscillations. And the frequency of LC oscillations are given by omega naught is equal to 1 by square root of LC, and finally 2 pi n naught is equal to 1 by square root of LC, and n naught is equal to 1 by 2 pi into square root of LC. So this is the frequency of LC oscillations. So once again, all of you see the diagram and the duration part and everything. See, initially this is K2, this is the cell, and this is the K1. See, initially K2 is open and K1 is closed. Then what is happening? If the K1 is closed, the cell is supplying charge to the capacitor, and it is supplying potential, and the capacitor is fully charged. If it is fully charged, now the K1 is open. If the K1 is open means the total circuit is removed. Then it is K2 is connected. Then whatever the energy is there, electrical energy is maximum. The electrical energy is given by half CV square of Q square by 2C. When it is connected to inductor, then this electrical energy is slowly passing through the inductor. The current is passing, magnetic flux is changing, and finally it stores the energy in the form of magnetic potential energy that is given by half L square. Then once it is completely discharged, once it is converted into electrical, is converted into magnetic energy, then afterwards it doesn't have any current to send to that one, and flux linkage will be stopped, and here also magnetic potential energy also will stop. Then afterwards this energy is discharging, and the capacitor is recharging in opposite direction, and once again this magnetic energy is converted into electrical energy. Suppose the capacitor and inductor, the both are not offering any resistance, then the energy is oscillating between capacitor and inductor, and such oscillations, such undamped oscillations, we will call it as a LC oscillations. And the frequency of LC oscillations are given by the same equation: omega naught is equal to 1 by root LC, or 2 pi n naught is equal to 1 by root LC, or n naught is equal to 1 by 2 pi to square root of LC.